In this session, we will discuss about the random variables. When we are going to discuss on the random variables, these are the things that we are going to cover up in this the module for this random variables. First, we will look what is meant by a random variable, what are the different types of random variable, and how to define the random variables for a given statistical experiment. And then based on the behavior of the data, we can divide it into two categories such as discrete and continuous. Then we will discuss on that matter as well. And then we will have some definitions for probability distribution, and will try to distinguish the discrete probability distribution and continuous probability distribution. And thereafter, we will discuss on how to define mean and variance, mean, variance, and standard deviation for a probability distribution. We will discuss it for the discrete probability distribution and then for the continuous probability distribution. Actually, these are the 6 questions that I have asked you to provide the answers. Then when you are providing the answers, it means that we will be able to complete the theories which is related with the random variables. First, we will look only what is a random variable. In statistics, random variables are used to study of probability. Therefore, if you are going to study the concepts of probability, then the random variables are widely used. And then generally a random variable is represented using a uppercase letter. We are just using this like this letter X to represent a random variable, and a random variable is meant to be a quantity being measured. Therefore, if we are measuring some quantity, then the measured quantity can be assigned to a random variable. A random variable can be again said to be, it is just a rule that assigns a number to each outcome of an experiment. It is quite like this. Before moving to the remaining part, I will briefly explain this. Now think about if you are tossing a coin. If you are tossing a coin, then you may have the outcomes as, if you are tossing a coin, then you may get either head or tail. Therefore, you can assign x equals h for obtaining a head, or else you can say that x equals t. Therefore, obtaining a tail can be again assigned for x. Therefore, the possible outcomes of this x is said to be h and t. Here, these are the outcomes, and then this x is what we are calling as the random variable. Therefore, the quantity being measured is meant by the random variable. If I'm taking another example as, if you are measuring the heights of the students, if you are measuring the heights of the students, then you can say for the first student, x will be, if this is named as x, then x will be, if it is in just in centimeters, then we will have it as 170. Then for the next student, we can have it as 156. Then for the third student, it can be just 163. Therefore, if you are considering the measuring the heights, then this can be denoted as x, and the possible values of x can be 170, 156, and 163. Likewise, you can have the values for the random variable, and here x has given for the measures of the heights, and this can be called as a random variable. And then if you move for the next part, these numbers are called the values of the random variable. Now we had an idea regarding what is random variable, how we are assigning the values. And then we have to move on the identifying the categories of random variables. If you are moving for the categorization of random variables, basically we can categorize it into two categories. The first one is the discrete random variable, and the second category is the continuous random variable. These are the two categories of random variables that we are considering. Um, and in this part, I have already discussed, we are using the uppercase English letters to denote a random variable such as x, y, z. Uh, we can have p, q. Likewise, we can have the uppercase English letters to denote a random variable. Now, I have mentioned that random variable can be categorized into two categories such as discrete random variable and continuous random variable. Now, we will look on these two separately. What is meant by a discrete random variable and what is meant by a continuous random variable. Discrete and continuous random variables. If the random variable can take only the countable values, such we are saying as 0, 1, 2, 3, likewise, it means that if you can have the values on the number line, if it is 1, 2, 3, likewise, 3, 4, likewise, you may have the countable values for x, then we can say x is a discrete random variable. X is a discrete random variable. In the other way around, if you can think on this way, if you do not have any value in between 1 and 2, or 2 and 3, or 3 and 4, then we can say x is a discrete random variable. It is because if you are considering any two consecutive values, there is a clear cutoff. 1 is just for 1 and 2 is if it is exactly 2. There is no 1.5, nothing like that. The very simplest example can be taken as number of students in a classroom. If we are having the number of students in a classroom, then we can have it as 70, then 71, 72, then 75. We can have like this. But never you can see that it is 75.5. There is nothing like that. Therefore, in such situations, there is no any halves or decimal for these discrete random variable. No any, but we are not saying this halves. There is a clear cutoff between two consecutive values. But if you consider on a continuous random variable, if you are considering x in the continuous scale, continuous random variable, in this situation, what we can say as xc can be taken as an interval of values. As an example, if you consider the temperature, if x is the temperature, then we may have the 30 Celsius and here it is 31 Celsius or 30 degrees and 31 degrees of Celsius. X is measured temperature and measured using the measurement as the Celsius. Then this can be 30 degrees and 31 degrees. But if you consider only 30 and 31 degrees, if you consider 30 degree and 31, if I am magnifying it, then we can easily identify 30.5 is here. Then if in between these two, there may be 30.2. Then here we may have 30.1. Then in between this, it is 30.05. Then if you consider on here, it is 30.007. Likewise, there may be infinitely many values in between any two consecutive values. It is quite like an interval. In the other way around, it is quite like a gradual increasing. It is because if you are considering the temperature, if it is from 30 to 31, if you are having the value as this and then this is 31, you cannot have it in this way. This cannot be happen for continuous scale. It is because we all know that temperature is gradually increasing. Therefore, if this is 30 and 31, the points are connected with somewhat a sloping line. But if it is discrete, then if we are having a value, then up to this point it is constant, and then and only it is just having an upward or downward. Likewise, that is how we can distinguish between the discrete and continuous random variables. In simply, we can say if we are taking an interval of values, it is a continuous random variable. If we are just assigning countable values for a random variable, then it would be a discrete random variable. And here there are several examples mentioned here to finding out the random variable and to identify whether the random variable is discrete or continuous. If you are considering an statistical experiment as the measuring the daily rainfall in inches, this is the experiment we are having. Experiment is measure the daily rainfall in inches. This is the experiment we are having. And then after this experiment, what we are doing, what we need to do is we need to identify what is the random variable associated with this experiment and what is the category, whether it is discrete or continuous. We need to identify whether the random, what is the random variable, and then what is the type of the random variable. We'll see how we can do it. If this is the measures the daily rainfall in inches, then we can have x. So if you are naming the random variable using letter x, then this can be have as the amount of rain each day in inches. It is because if you are measuring the daily rainfall, then if this is the day number, then you may have day 1, 2, 3, 4 likewise. Then you can have the measure the rainfall. Then you will have in inches. In inches, you may have several values. Therefore, this is what you are measuring. Therefore, you are measuring the daily rainfall in inches. Therefore, the amount that you have got as the rainfall will be the random variable. And since you can see it is length, you are measuring in inches. Therefore, length cannot be just as two discrete points. Therefore, it will be just as a continuous connection. Therefore, this variable is said to be a continuous random variable. And the next experiment is counting the number of sewing machines in an industrial zone. Here you are going to count the number of machines. Therefore, number of sewing machines in the factory can be considered as the random variable. Here, using an uppercase English letter, it has named as y equals number of sewing machines in a factory. If you are counting the machines, there is no any half or quarter or three-quarter of machines. Therefore, this will be if there is one machine, then next it will be the second machine, and then three machines, four machines. Likewise, you may have a clear cutoff between any two consecutive values. Therefore, we can simply say such variable as a discrete random variable. And if you move for the next two examples, measure the weight of set of machines in kilogram. Here you are going to measure the weight of a machine. Then weight of a machine in kilograms can be considered as a random variable, and here it is denoted as the uppercase English letter Z. Since you are weighing a machine, it means that weight in kilograms. If you are considering 1 kilogram and the 2 kilogram, if you consider simply in this region, there are infinitely many more values in this interval. Since this can be considered as an value interval, then definitely this random variable has to be categorized under continuous random variable. Then the next one is counting the number of defective light bulbs in the case of bulbs. Here we are counting the number of bulbs. Therefore, the number of defective bulbs that we can identify in the case of bulbs can be considered as the random variable for this experiment, and it is denoted as the uppercase letter T. Therefore, we can say this T equals number of defective light bulbs in a case of bulb. And this is also a discrete random variable. It is because now consider if there are two defectives and three defectives, there is nothing in between these two and three. There is no any values in between two and three. Therefore, if it is two, then it is exactly two, or else if it is three, then it is exactly three. There is no any 2.5, 2.7, likewise that. Therefore, the number of bulbs can be considered as a discrete random variable. This is the very basic idea on the random variables, and then we will move to focus on the probability distribution. First, you have learned, we have discussed on the random variables. Now, if you are assigning the probability to these random variables, if you are assigning the probabilities to the levels of random variables, then we can easily made up a probability distribution. Therefore, we can say the probability distribution of a random variable x is a list of distinct numerical values of x. It means simply the values of x we are having as 1, 2, 3, 4, any other values we can say, or else if you need, you can say this as if it is the temperature, it is 20 to 25, then 25 to 30, 30 to 35. Likewise, you may have a range of values. Therefore, it can be discrete or continuous. And if you are assigning the values, then it is the probability of x. We are saying it as the probability of x. Then, if this is 0.3, then this can be 0.2, then 0.4, and if it is 0.1, then we can say such arrangement as a probability distribution. Then when we are discussing on this, here we can simply say, once we are assigning the probabilities for the distinct numerical values of x or the random variable, then such arrangement is meant to be a probability distribution. This is a probability distribution. And if we are considering this as well, here we are having x in continuous scale, just as the continuous variable. If it is in the 20 to 25, we will allocate the probability as 0.3. If it is in here, I am allocating the probability is 0.7, 0.5. Then here, I am allocating probability as 0.2. Then you can see that these probabilities are also representing a probability distribution. And generally, we can write down the probability distribution in the tabulated form. We can write this in the tabulated form, or else we can write this probability distribution in the equation form as well. If it is defined as a special probability distribution rather than using tabulated form, we are preferred to use the equation form. But for any given tabulated form, using some mathematical concepts, we can easily identify the equation form for this tabulated form as well. At the beginning of the discussion on the random variables, I told that random variables can be divided into two categories as the discrete and next one is continuous. And we have said the next thing is we are assigning the random variable, we are constructing the probability distributions for this random variable. This is the next thing we are doing. Since we are constructing or we are identifying the probability distributions for random variable, then according to the behavior of the random variables, we can again assign this discrete concept and the continuous concept in the probability distributions as well. Therefore, we can say that probability distributions. Probability distribution has also two categories. Number one is discrete and second category is empirical. These are the two categories we are having for probability distribution, discrete probability distribution and then the continuous probability distribution. Now we will focus on the concepts on the theories on the discrete probability distribution and then the continuous probability distribution. First, we will discuss on the discrete probability distribution. If we let that x is a random variable and it is forced into the discrete category, then we can say that x is a discrete random variable. If x is a discrete random variable, then if you are assigning the probabilities for such a discrete random variable, then we can construct a discrete probability distribution. And once you are constructing a discrete probability distribution, I told you that you can write it in the equation form. If you are writing the discrete probability distribution in the equation form, the function you are writing is said to be as the probability mass function. This is said to be the probability mass function abbreviated by PMF of x. We are saying that if x is a random variable, the probability mass function of this x can be written as fx. Generally, we are using the lowercase letter f to denote this probability mass function. Then we can write down this simple fx. This is the probability mass function we are having. We can say that probability of x equals xi. Ith value of x, if we are assigning the ith value of x to the variable x, then its probability is denoted by px equals xi. And here we can say that xi belongs to set of values of x. Otherwise, we are saying generally, we can say that value is 0. And this is the general form we are writing it. And I am taking this as an example. If you are tossing, if you are rolling a die, consider the example on rolling a die. If it is a balanced die, we'll let it as a balanced die. Then we all know that getting a number on the surface will be having the equal probabilities. It is quite as if x is the number appears on the surface. Since the die has 6 sides, then 5 and 6 will be here, the numbers on the die, and the probability that obtaining 1 is 1 over 6, 2 is again 1 over 6, 1 over 6. In this way, you may have the probability values. Therefore, this is the tabulated form we are having. Therefore, if you are saying that x equals 1, then the probability that x equals 1 is equal to 1 over 6. That is what we can say by the first row. If you are assigning the value of x equal 1, then the probability of getting x equal 1 is 1 over 6. It is because there are altogether 6 sides, and among these 6 sides, we are having only one side naming as 1. That is why we can say this as 1 over 6. Similarly, we can say that x equals 2. Then the probability of obtaining x equals 2 can be written in this way. It is again 1 over 6. Then x equals 3. Probability that we are getting x equals 3, 1 over 6. Likewise, we can have, if it is x equals 6, we can have this as probability of getting x equals 6 is 1 over 6. Now consider on the x equals 7. If you are considering the equation x equals 7. Since you cannot see any 7 on the die, the probability of getting x equals 7 is definitely equals to 0. It is because there is no any number naming on the die as 7. That is why we are getting this as 7. Therefore, if you are trying to write this in the equation form, then you can easily write the equation in this form if this is the probability mass function you are having. Now you can see that for all the values of x starting from 1 to starting from 1 and ending by 6, you may have the probability as 1 over 6. Therefore, we can say that probability is equal to 1 over 6, where that x equals 1, 2, 3, 4, 5, and 6. And you can see that otherwise this value is equal to 0. Therefore, this is how we are constructing the probability mass function. And if you are discussing on the probability mass functions, then there are two properties that we have to focus on. If you are considering any given probability mass function to be a valid probability mass function, these two conditions are needed to satisfy. The first condition is each and every probability should be greater than or equal to 0. It is based on the fundamental laws of probability. Probability cannot be have a value which is less than 0. It means probability should be always a positive value. Or rather than saying as positive, it should be definitely non-negative. Means positive or 0 can be there. That is why we can say that this probability function should be having a non-negative values. And then you have to look on this matter as well. If you sum up the probability values of a probability function, this should be exactly equal to 1. In here also you can see that if you add all these values again, there are 6 1 over 6s. Therefore, the summation is equal to 1. Sum equals to 1. Here also you can see that obtaining 1 is 1 over 6, obtaining 2 is 1 over 6, likewise obtaining 6 is 1 over 6. It is quite like if you are getting the summation of all these 6 values, then this should be exactly equals to 1. Therefore, this is the second condition that any probability mass function has to be satisfied if it is a valid probability mass function. And now we will move for the next part. It is the continuous probability distribution. For the continuous probability distribution, we can say that if the random variable is a continuous random variable, then we are saying that the probability distribution associated with that random variable is a continuous probability distribution. If the probability distribution associated with the continuous random variable is said to be a continuous probability distribution. And the continuous probability distribution, then if we are writing it in the equation form, then we can say such function as the probability density function, not as the probability mass function. We are saying this as a probability density function, and generally we are abbreviating it as the PDA. And here also we can say that probability distribution function as fx. Here we can say that continuous probability, since we are not having any point values, then we will have this as the continuous probability distribution function. Therefore, for a range of values, we will have the probability. It's just for a range of values. Then there may be for another range of values, some other values, and then otherwise, if it is not falls into one of these regions, then you have to assign another set of values. Therefore, the next thing is what we are going to discuss is the properties associated with the continuous probability distribution. Here we can say that For all values of x, the probability density function should be a non-negative valued function. This should be a non-negative value. It is because no negative values cannot be can have for no negative values can have for the values of probability. Therefore, always you must have the non-negative values as the probability. Then next thing is if you are integrating a continuous probability distribution function. In the discrete probability, we got the summation and use the fundamental concepts of the integral. Then if you are integrating a continuous probability distribution function from minus infinity to plus infinity, if you are integrating this probability function with respect to x, then you will get the value as 1. You will get this value as 1. Is that the summation of probability distribution is equal to 1 here. Once the variable is in the continuous form, then we will have the integral of that. Now we will move for the having the idea on the cumulative density function. In the probability distribution function, we had only the point values only. But for the cumulative density function, we always looking for a value. The probability is up to a distinct point of x. It is quite as in the previous we had the probability that x equals to x. Now in the it is for the PMF or the PDF, PMF or the PDF. And now for the cumulative density function, we are looking for x less than or equal to some defined value of x. This is what we are saying as the cumulative density function. Then this is abbreviated as CDF. According to the behavior of the random variable, whether it is discrete or continuous, we are identifying the cumulative density function in these forms. Generally, we are letting this by this uppercase letter F. For the PDF or PMF, we had the lowercase letter. For the CDF, we are having FX. Here, this Fx is said to be, it is Fx plus the probability. If we are saying that Fx equal to xi, this indicates that the probability of x less than or equals to xi. This is what we are saying as the cumulative density function. To get this value for a discrete random variable or for a discrete probability distribution, we can get this as this fx equals xi can be obtained as the summation summation of xi goes from 0 to xi. Here we can say that summation of I goes from 0 to xi, that we can say it is the probability of x equals xi. I goes from 0 to xi. Then if it is, this is for the discrete case, but for the continuous case, we have to look on this. We are taking this fx as we are, rather than using integral, using the summation, we have to use the integral. This is starting from negative infinity and end up with the xi value, and here we need to have this fx dx. Here we can have this px, or here also we can have fx. But the difference is for the discrete, you are getting the summation, and if it is continuous, you are using the integration. This is how we are forming this discrete and continuous cumulative density function for discrete and continuous probability distributions. And here we will discuss on this matter using an example. Here, a student has tossed a balance coin for 3 times and the values of the surface was noted. And if you see on this example, if you are considering a coin, then we may have two sides. If you are tossing a coin, you may either get head or tail. But the student has tossed a balance coin for 3 times. Therefore, here we are having 3 instances. Therefore, for the first one, you may get either head or tail. For the second one also, you may get either head or tail. And for the third one as well, you may get head or tail. Therefore, if you consider on the outcomes of this tossing a balance coin for 3 times, then you may have the equal chances of getting head or tail. Therefore, for the remaining 2 times, you may have the equal probabilities. Therefore, first we will identify what are the all possible outcomes, and then we can say that since it is a balance coin, we are having the equal chances of getting one outcome. Therefore, if you consider only outcomes, then this can be considered as in the first toss you may in the first coin you first toss you may get a head, then again head and again head. This would be one outcome. Then head, head with the tail, next outcome. Then head, tail with the head, tail with the tail. Now it is the first, second, and now we'll move for the third one. If you may get in the first toss it is tail, then again two heads, tail, head with another tail, tail, tail with head, and tail, tail with tail. Now you can see that there are altogether 8 possible outcomes I have included. Those are the possible events of tossing a fair coin for 3 times experiment. Since it is given as a balance coin, then we can say that all these events would have the same chance of occurrence. That is why we are saying the probability as 1 over 8. It is because here we are having altogether 8 outcomes. Since we are having equal chances, the probability for each getting each event is same. That is why we are getting 1 over 8 for all these 8 outcomes. Then to get the cumulative probabilities, we are assigning the first value as it is. Then this value is added to the next row value, sums up the value as 2 over 8. Then the 2 over 8 added to this 1 over 8, then this will become 3 over 8. Added to this again 1 over 8, then this will be 4 over 8. Likewise, you may get at last it could be 8 over 8. That is why we are getting this as 1. Therefore, if you are constructing these cumulative probabilities, then at the last row you may get the value as 1. Here I have shown this using a diagram. Here the events as given for all the 8 events, the probabilities as given. 1 over 8 itself equals equals to 0.125. You can see that all probability values are lies on this constant line as 0.125 for all for each of these events. And you can see that cumulative density function has just as a grown up line, and you can see that the line here is given as 1. It is because you can see that cumulative density, the maximum you can get is 1, and here for the first event it is given as 0.125. Likewise, you can construct the cumulative density function for. Here it is just obtain the graph for cumulative density function and the tabulated form as well obtained for this example. And then we will focus on the expectation for the random variables. For the expectations of the random variable, here we will just say if x is a discrete random variable, if x is a discrete random variable, and if this x can be take the values on the set D. We are defining set as D and having the probability mass function as fx. If we are having the probability mass function as fx, then the expected value for x. In other words, we can say the mean value or the average of x can be obtained as the expectation of x, and this can be obtained as the summation of x times fx for the through the all possible values of x throughout this set D. In simply, you can say that this as mu or x bar is just saying as the expected value of x, and this can be said to be a summation of x times fx. Or in simply, this is the simplest format. You can say instead of fx, you can use the value px. This is xpx is said to be the mu or the expectation that we are obtaining. This is for the if we are having a discrete variable. If x is discrete, then we are using summation. But in the case of continuous random variable, then we can say this mu is the expected value of x. Then this can be again obtained as x times fx. And here we need to integrate this with respect to x. It is actually not from minus x. Here it is x fx from the minus infinity to plus infinity. Therefore, if you are having a continuous random variable, then the mean value can be obtained as getting the integral of x times fx with respect to x for the interval from minus infinity to plus infinity. Therefore, this is how we are getting the expected value for a random variable. And then we will move for the obtaining the variance of random variable. Actually, expectation can be considered as the first moment of this random variable, and if you move for the second moment, then it is defined as the variance of random variable. But here we are not going to discuss that much things in this session. Therefore, we can simply say that variance is the second moment. Therefore, we can say that variance denoted by sigma square. This can be considered as the expectation of x minus mu to the power 2. Expectation of x minus mu to the power 2. And if you simplify this, then you can to obtain this quantity, you can just guess the summation as summation of x minus mu to the power 2 times fx for all the values included in the set D. This is the general way that we are using, but most of the time we prefer to use this equation for the calculation. It is the ex squared minus ex to the power 2. It is because we can easily find out the ex using this equation, and we can write down this equation. Ex squared can be obtained as the summation of x squared times fx. It is the x squared. We all know that x is just equal to summation of x times fx. X times fx. Therefore, using these two equations, we can simply obtain the values, and then substituting in this equation accordingly, we can obtain the variance of a discrete variance for a discrete random variable. But anyhow, the rule that we are using is the second moment for a variable. Then the concept is this. Then if you move for the obtaining the variance of random variable, if it is a continuous random variable, then what we need to do is we need to just replace this summation with the integration only. It is the only thing we have to do. If we are having a continuous random variable, then we can have this as sigma squared is still x minus mu to the power 2. Then this can be obtained as sigma square. You have to integrate this from minus infinity to plus infinity. This is equal to x minus mu square times fx dx. This is how we are obtaining this sigma square if x is continuous. If x is continuous. Now, using the things that we have discussed so far, we can apply it in an example. Here we can see that the data collected over 200 days and tabulate the number of calls in a day incurring for a technician for a machine repair in an industrial zone. Here it is considered 200 days and they have monitored number of calls that they got each day for asking for a technician for repair of any given machine in an industrial zone. Here we can see that the data given as number of calls received, and this is the observe. This is the thing that you are observing. Therefore, this can be considered as the variable. Therefore, our variable is number of calls received. Then here we can see that number of calls received is starting from 36 to 45. The minimum was 36 and maximum was 45 per day. And the number of days that they got such number of calls is, in simply we can say they got 36 calls in a day. There were such 5 days, and there were some days they got 37 calls per day. There were 10 such days. Likewise, you may be able to understand the given data set. Here it is 40. In this last row says that there are some days having 45 calls per day asking for technician, and there were such 15 days. And if you consider about this set of days, now you can see that the summation of days equal to 200. It is because we have considered it for 200 days. And the probabilities of obtaining getting this call can be obtained in this column. To obtain this, we will discuss this obtaining probabilities in detail in the next section. But here I will briefly explain how to get these values here. Without no need to worry with these xi values, only with the frequencies we can easily obtain the probabilities. Here we can see that there were 5 days out of 200. Therefore, this row can be filled as 5 out of 200, which equals to 0.025. In here, we can see that there were 10 days out of 200. That is why we are getting 0.050. Again, another 10 days out of 200 discounted. Likewise, here it is 35 days out of 200, results the value as 0.175. Here it is 15 days out of 200, then this equals to 0.075. Likewise, we can obtain the probability. Therefore, this here we can say that if you are constructing only first 3 columns, then this can be considered as your probability mass function. If you are writing it in the equation form, you can say probability of x, and you can write down the probability values. You can see that when x equals 36, we are getting probability as 0.025. We are getting 0.025 as x equals to 36. And as x equals 37, we are getting the probability as 0.050. And it is same for the 38 as well. Therefore, x equals 37, 38. And then if you see another value is equal to these two, then there is nothing. We have finished these 3. Then the next value that we can get is here it is 0.10. Then this is obtained for x equals 39. X equals 39, we are getting this value. And if you observe for any other values, there is nothing more than this. Then next probability is 0.125. It is for the value 20, it is for this value 40, x equals 40. When we are getting this, then another two values are there, 43 and 44. Then 43 and 44, x equals 40, 43 and 44. The probability of getting this much, of course, is 0.125. Then the next value we can see is 0.15. 0.15 means here we are having this as x equals 41. Then next one is 0.175. 175 means where x equals 175 got as x equals 42. Then the last one we are getting it as 0.075. 0.075 where x equals 45. Therefore, this is the probability mass function that we can create for the given example. This is the probability mass function that we can create for the given example. And here it is in the tabulated form, and then it has converted into the equation form as well. Then cumulative probabilities, you can get the summation. Here we get the value as it is. Then this has to be added to the value in the next row. That's why we are getting 0.075. Likewise, you can get the cumulative probabilities. Therefore, in the last row, you must get this value as 1.000. It is because you all know that the summation of probabilities cannot exceed 1. That is why we are getting the cumulative probability maximum value as 1.000. And here also we can identify the same thing. If you are getting these probability values, the summation of these probabilities should be equal to 1. That is why I am getting 1 here. It is because in the what we are saying as in the theory, it is stated as for the PMF to be a valid PMF. This is the condition that we have considered. The summation of fxi should be equal to 1. That is what we have obtained. There are also as well. Here we have obtained the summation as 1 for all the probability. And this is how we are constructing the cumulative probability function as well. If you need, you can say you can write down the CDF as well. If you need to write down the CDF, you can say this as fx. We can say it is 0.025 as x less than or equal 36. Then 0.075 as x less than or equal 37. 0.125 x less than or equal 38. Likewise, you can fill up the values. Then 0.925, it is as x less than or equal 44, and 1.00 as x less than or equal 45. Therefore, this is what we are getting as the CDF for this example. CDF, cumulative density function. And here it is given as calculate the mean number of calls that they are getting for a day, asking for a technician. Therefore, using the concepts that we have discussed here, to calculate the expected value or the mean value, what we need to obtain is we can use this equation summation x times fx. But in this table, we have the values of x, and here we are having the values of fx or values of px. Since we are having both these values in the same table, I have created the column as x times fx, or we can say this as x times px or x times fx. Then this value has to be multiplied with this 36. Then we got the value as 0.900. Then 0.5 multiplied with 37 gives the value as 1.85. If I randomly choose this value, 0.150 multiplied with 41 results the value as 6.15. Likewise, we have to get the multiplication for these two columns for each row. Then if you get the summation, it is because to get the value for the, we are getting the expected value. This is obtained as summation of x times fx or x times px. This is the summation of x times px. Then we can get the summation here. Here we can see that the value is equal to 41.300. That is why we are getting the mean value as 41.30. And you are asked to calculate the variance for the above example. Here, if you need, you can calculate this using this equation using x minus mu squared times fx, or else you can use this technique as well. Here we can say that sigma squared can be obtained using ex squared minus ex to the power 2. Using this, so far you have identified this ex as the 41.3, and now you can consider its squared term, and then you have to consider this ex squared term. But you know that ex squared is given as summation of x squared times px, or x squared times summation of x squared times fx. Then we need to calculate this quantity. Therefore, first what we need to do is you need to create a column for x squared. Then x squared has to be multiplied with this column to get the value for x squared fx. X squared fx is obtained. Then you need to get the summation of this. This is what we are calling as summation of x squared fx. This is what we are obtaining as the ex squared. Then this quantity can be applied here to do the calculation, and likewise we can obtain the variance for the given example. And this is all what I need to discuss for this session, and thank you all for participating with this session.